session. Yeah, let's start. Thanks for joining. This will be the last collab for pertaining to the learning units that I'm going to cover. So we should finish up all the learning units by today. So I'm continuing with the ChiSquare distribution. So hopefully what we did last week is still fresh in your mind. Let me share my screen and we can work through an example. So just give me a heads up once you can see the whiteboard, which says an advertising agency wanted to establish. All right, fantastic. Let's go back. All right, so last week, as I mentioned, there's three ways you can use a chi-squared test, right? So one is for test of independence, and that was what we did last week. Second one was for equal proportions, and then the third one is the goodness of fit test. So we've done the first one last week, and now we're going to go over the second and the third. But if you recall from what I mentioned last week, these two tests are very, very similar. Okay, so I won't spend too much time on the calculations here because the calculations are the same as how you do the test for independence. But I will cover it so you have an idea of how to go about answering the test for equal proportions. All right, and then I'll finish up with the goodness of fit test. So this example that I have here is a test for equal proportions, right? Now I just need to give you a heads up that in your exam, don't expect the question to tell you which test to use. Okay, you have to use your discretion and look at what they're asking, and you have to decide which of those three tests you need to do. All right, but generally, for tests for independence, it's pretty easy to spot that because they'll use a word such as association or independence. All right, so you'll know that that's the test you're using. For the equal proportion test and for the goodness of fit test, that can be kind of blurred, right, or which test to use. But I'll try and give you some information to help you in deciding which one. All right, so let's read this question and then kind of give you a better understanding of the test for equal proportions. Right, so the question says an advertising agency wants to establish if the proportion of people who read a particular magazine's sports news was the same across 3 geographical regions, right? And that's 3 provinces listed below in the table. There was a total of 300 readers, and they were randomly sampled. 3 regions, specified below, show the readership numbers, right? So they basically tell you whether they read that specific sport news or not. So that's why if you look at the row variable, no and yes. For the 84, it's saying 84 people in the Eastern Cape do not read, whereas 16 do. All right. So you're testing the proportion of readership across the 3 provinces. So the first question says, formulate an alternative hypothesis and test whether the advertising agency can assume equal proportion of readerships, right, across the sports news. So this is already a dead giveaway that you're going to use test of equal proportions. This part here, equal proportions, right? So you know you're going to use that test, option 2. All right. So we're going to state the alternative and the null hypothesis. So that's your step 1 for hypothesis testing. So step 1, you're going to have to stipulate your H0 and your H1. All right. Now you can see that there are 3 provinces, right? So because there are 3 provinces, there's going to be 3 proportions, and the symbol for proportion is pi. So what we're saying in H0 is that they're equal proportions. We're saying pi 1, and pi 1 can be Eastern Cape, right? Doesn't really matter. Pi 2 can be Western Cape, and pi3 will be kzn. So we're saying all of these proportions are equal. Okay, that's what we're testing for H0. We're testing that the proportions are equal for all three provinces. And then for H1, if it isn't this, if this is what you're thinking, it isn't pi1 not equal to pi2, not equal to pi. That isn't what we do for hypothesis testing for the chi-square distribution. All we care is that one of them differs. So that means we could have pi1 equal to pi2, but then pi2 is not equal to pi3. Or it could be the other way. This could be not equal to, and this could be equal to. But we don't really care. We only care that one of them differs, and that's all you need to state for your alternative hypothesis. All you need to say is that at least one province differs. That's what you need to state. Okay, does that make sense, everyone? Before I move on to the next question. Everyone following or anything unclear? All good? All right, let's move on. All right, so that's just step one. Now your step, remember there's 5 steps to hypothesis testing. There's step 2, 3, 4, and 5. These 3 steps are identical to the independence test that we did last week. You follow the same procedures that we did last week to answer step 2, 3, 4. Only step 5 differs because you need to state a different conclusion. All right. So I'm not going to go into the details of the calculations for 2, 3, and 4 because I did that last week. And you just need to do that exact same steps with this problem, and you will get the same the result that you need to get for this test. Okay. So I'll just put the answers here for step 2, and you can, when you do it as an exercise, which I encourage you to do, you compare it to what I have. All right. So for step 2, you need to find the critical region, right? The region where you reject your null hypothesis. And that critical value, I'll just draw it. Maybe it would be better if I do the sketch. So here's your axis. Okay. Our critical or level of significance for rejection is 0.01. So here it's 0.01. And your critical value is 9.21. All right, so anything greater than this, we reject H0. Otherwise, we accept H0. That's just step 2. Step 3, we'll calculate the test statistic. Remember the test statistic, you need to create a table with all your, remember you'll have no here, yes here, and then you'll have your 3 regions, Eastern Cape, Western Cape, KZN, etc. And you repeat these for the yes, you get your F0, get your FE, and eventually you get your chi-squared test value. Okay, just like how we did last week. So I'm going to erase that. I'm just going to give you the test statistic. Tell you what it is. Chi-squared test. That is equal to 7.595. 5. Sorry, pen is irritating me here. 7.595. Okay, and then now step 4, do we accept or reject H0? So looking at what we got for our test stat, and this is our rejection region, do we accept H0 or do we reject H0? What do you think? What is your guess here based on the result from step 3? Very good. Well done. We accept H0, all right? Because it is less than 9.21. So we accept H0. So all of these steps, and I know I didn't go into detail with them because, and the reason is because I covered them last week, so I don't want to have to go back and redo that. But from judging from how the call went last week, I gathered that everyone understood how to do the calculations. So this shouldn't be a problem for you. So here, this is your step 4, you accept H0. So it means if we're accepting H0, then we believe this is true. So how we would conclude this, and this is the difference between last week and this week, is how you conclude this. Because last week, we concluded in terms of being independent or not. Here, we're talking about the proportion being equal amongst the 3 provinces. So what you would say, and let me just write this in text instead. Right here, if you remember what we always do, we always start off with our level of significance. So we would say at a 1% level of significance, all right, we accept H0 or we do not reject H0. Either way, it's fine. We do not reject H0. And then we will say we conclude there is an equal, let me do the next line, equal proportion of readership amongst the 3 provinces. That's it. That's what this is what you would conclude. At a 1% level of significance, all right, we do not reject H0, and we conclude there is an equal proportion of readership amongst the 3 provinces. So for last week, the 2 steps that are just different from what we did last week is this step 5, and step 1. All right, everything else is pretty much the same. All right. Any questions before I move on to the goodness of fit test? Because that test is different to what we've done so far. But just want to take any questions or on what we've covered so far before we move. Oh, good, fantastic. All right, so I'm gonna close this and open up goodness of fit. So only a change in wording. Yes, Kai, exactly. That's it. It's only a change in wording. The calculations are exactly the same. All right. So let's move on now to the goodness of fit test. Now this test, the calculations are different. All right. So I'm going to go into a bit more detail into this test. All right. So let's look at this question, and then we'll take it from there. The financial officer of an electronics goods company sells TVs, sound systems, etc., and is known from past experience that 23% of the store's customers pay cash for their purchases. 35% of them pay by debit cards, and the remaining pay by credit cards. So you want to confirm that there's still the same payment method of these electronic goods, all right? And then what they've done is they've taken a sample of customers, right, 200 of them, excuse me, and then they've looked at what payment methods they use. Okay, so now they've observed that out of the 200, 41 of them pay by cash, 49 pay by debit card, and 110 pay by credit cards. And so the question is, use the ChiSquare goodness of fit test to determine whether the payment patterns of the past are still relevant today. Now, this question specifically tells you to use the goodness of fit test, but don't bank on the question telling you to use that test. The question could also say, determine if the distribution of payment methods has changed. Okay, that could be the question, right? And how you could determine if you're using a goodness of fit test is look for the words distribution, right? And also look as to whether you're trying to determine if the distribution is different over different time periods, all right? And that's what's happening here as well. If you look at it from past experience, okay, they have observed that it was 23% that paid by cash, 35% that paid by debit cards, etc. And now there's a more recent sample, all right? And they want to determine, so say, for instance, previously 23% paid by cash and 35% paid by debit cards 5 years ago. This sample could be done last month, okay? And now we want to determine if the payment distribution is the same as it was 5 years ago. And that's a giveaway that you need to use the goodness of a test, right? Am I clear on that? Anything unclear? Just let me know in the chat. Yeah, fantastic. All right, so let's start solving this problem. Okay, so for the goodness of a test, your first step for your hypothesis testing, you remember your H0 and H1. So I'll write it here. For the goodness of a test, there actually isn't math symbols, so any numbers you need to write for H0 and H1, sorry. You're actually just using words. Okay, so for H0, what you would say is that the distribution of payment methods is the same. Distribution of payment methods is the same. Okay, so H0 will always be the case where the distribution is unchanged, okay? It's always the same. And you always need to specify in terms of the problem what you're stating for H0. So for us, it's payment methods. So don't just say the distribution is the same, okay? Say the distribution of, for this example, is the payment methods. So you'll say the distribution of payment methods is the same. And then H1 is just the opposite of that, okay? All you need to say is the distribution has changed. That's all you need to say. Distribution has changed. Okay. All right. So that's just step one. Now let's move on to step two. So I'm just gonna maybe draw a line here. All right. Step two, find our critical region or the region of rejection. All right. So now remember we're working with the chi-square test. So it's going to be the same kind of sketch with our critical region being on the right. That's a curve like that. Okay, now the size of this area is given in the question. It's 5%. Alpha is 0.05. So it's 5%, 0.05. All right. Now remember, for the critical value, apart from the alpha, you also need to know the degrees of freedom. Now previously, to work out the degrees of freedom, the formula was R minus 1 into C minus 1. That's how it was for the previous two tests that we did, for the independence test and for the equal proportion test. But for the goodness of fit test, it's different. Okay, so this doesn't apply here. For the goodness of fit test, you're going to use the formula, the degrees of freedom is equal to K minus M minus 1. Now you need to memorize this formula, okay? Unfortunately, it's not given to you. And I'll explain what each of these symbols mean. Okay, so for the goodness of the test, it is K minus M minus 1 to get your degrees of freedom. Now, K is the number of classes that you have. Number of classes. So look at the table that's given to you. If you look at how many classes are given to you, so basically how many categories are there? Well, there's only 3 categories. It's cash, debit card, and credit card. So your K is 3. Now for your M, it's the number of parameters. Now for this value, okay, and unless they tell you it's a normal distribution or Poisson distribution or a binomial Poisson or normal distribution, your M is always 0. So for this case, your M is 0. So a handy table in your textbook to refer to is here. Let me just show you that. It's on page 3 it's page 305. So I'm just going to copy this table and put it in the whiteboard. Page 305, you'll see a table like this. Okay, your textbook. Now this is what this table tells you. The table tells you that if they're telling you to test whether the distribution is a normal distribution, then your M is 2. Okay, if they tell you that to test that the distribution is a binomial distribution, then your M is 1. And your M is also 1 for Poisson. For everything else, it is 0. So here in this question, they never mentioned anything about a normal distribution. Neither did they mention anything about a binomial or a Poisson. So our M is 0. Okay, let me just pause this for a second and check if there's any questions. Is everything clear there? So that table on page 305, yeah, it's not in your sheets. Oh, good. Okay. All right. So remember, unless they say that it's a specific distribution, then you'll need to specify M. Otherwise, just assume that your M is 0. In this case, our M is 0. So our degrees of freedom is 3 minus 0 minus 1, which is 2. All right. So now we have our degrees of freedom. Here we go. Oops. Okay, this is equal to 2. So that's our degrees of freedom. So now if you go to our table, our chi-square table, this table is given to you. Let's copy and paste it here. Right, there's our table. Remember, our degrees of freedom is 2, and our alpha is 0.05. So we would be using the value where the 2 and the 0.05 intersect, which is here, 5.991. All right, so that's our critical value. Oops. So I'm going to erase this. Oh, can't erase it. All right, let me just restart this board. Sorry about that. Give me a second. All right. So remember, step 2, we had our sketch. Okay, that was 5. And we said that the critical value is 5.991, I believe. Double check. Yeah. So anything above that, we're going to reject H0. Right? Otherwise, we accept H0. All right. So now let's move on to step 3, which is the bulk of the working. All right. So for step 3, what we're going to do is we're going to replicate this table that they're given to us. So we're going to have 3 categories. We're going to have cash. We're going to have debit card. I'm just going to put DC for debit card and CC for credit card. Okay. And then we have our observed frequency, F0. Okay. Put some lines here. More. Cool. All right. And all I'm going to put for F0 is what we see in our table, what's given to us. Okay. So our observed frequency for cash is 41. For debit card, it's 49. And then for the credit card, it's 110. So in total, there's 200. We add it all up. The other information that's given to us is the expected frequency, but as a percent. Okay, so your FE, but as a percent. If you read the text, it tells you that 23% of them pay by cash. Okay, so I'm going to put that there in this table. So it's 23%. Then by debit card is 35% of them. And then lastly, the remaining is 42% by credit card. Okay, so I haven't done any calculations. All I'm doing is I'm just putting the information they give us in the question into a table. All right, and now I'm going to start the calculations. Okay, now for the chi-square test statistic, I need to know FE values, as in the absolute values, not the percent. I need to know the volume. Okay, I know it's 23%, but what is the number exactly? And that's why we're going to use this total here. Okay, so think about this logically. Okay, if you had 200 people, right, and if it was expected that 23% of them paid by cash, then what would be the number? And how you would work that out would be 23% times 200, and that would be the number. And if you work that out, you'll get 46. Does that make sense, everyone, before I move on? This is your FE value. Fantastic. All right, so that's 46. And then I'm going to do the same thing for debit card. Okay, it'll be 35% times 200, and that's going to give me 70, and then the remaining customers will be 84. You could do you could do 40% times 200 to give you that, or you can just take the remaining customers from 200. All right, so that's your FE. And now the next few columns are pretty much what you've seen before. All right, I'm going to work out F naught minus FE whole squared. Okay, and then in the last column, it'll be F naught, it'll be this column here basically. It'll be F naught minus FE all squared divided by FE. So I'll write the values that I got here. It's 25, 441, and 676. To give you an idea or recap of how you got these values, remember this is F naught minus FE, and then you square the values. So there's your F naught, it's 41, minus FE, it's 46. So 41 minus 46 will give you minus 5, but if you square it, then the negative sign doesn't matter. So 5 squared is 25. Right, you do the same thing going down the rows. F naught minus FE, and then you square it. The next step is you're just taking this column here, and then you're dividing it by this column. That's all you're doing. So you're taking 25, and you're dividing it by 46. All right, and you get 0.54. 0.54. The next one, you'll get 6.3. And then the last row, you'll get 8.05. 8.05. And then last step is to add up all these values, get the total. And if you add it up, you'll get 14.891. 14.89. I'm just going to leave the two decimal places. And that is our chi-squared test value. That is our chi-squared test. Right. And then now in step 4, we can determine whether we need to accept or reject our H naught. Now, based on what we found in step 3, we compare it to your rejection region. Do we accept or do we reject H naught? What do you think? Very good. Yes, this 14 is way greater than 5.9, so we reject H naught. Very good, everyone. Let's give me a second. Going to, hey, well, we reject H naught. Very good. And now we're at the last step. Okay, so I'm just going to erase this step 2 once we're done with it. Okay, so if you remember in the beginning, we started off with declaring our null alternative hypothesis. Our H naught was that the distribution is the same. So the distribution, I'm just going to say this, distribution of payment methods is the same. That's what our H naught was. And here we're saying we reject H naught. So this is not true. So if this is not true, then what we're saying is that the distribution of payment methods has changed. And so now we're going to write it in words. This is our step 5. Step 5, we're going to write it in words. We always start off with a level of significance. So we say at, all right, okay, at a 5% level of significance, right? We reject H0, all right? And we conclude that the payment, we will say the distribution of payment methods has changed. And that is it. This is what you would write. 5% level of significance, we reject H0, and we conclude that the distribution of payment methods has changed. And how's that, everyone? Does it make sense? Happy? Anything you're not certain about? Oh, fantastic. All right, so I guess that the only thing left to write is the end. Yeah, that's all the learning units covered. All right. So yeah, there's nothing new that's left to teach, but I suppose I'll set aside some time to do some revision. What I would encourage, any questions? Yeah, it has flown. Time has flown. What I do need from you and for everyone else that's going to watch this recording is I need you to email me what learning unit you'd like me to revise. It's going to make it more feasible. Instead of having to revise every single learning unit, I'd rather focus on those that majority of students are struggling with. So if you can let me know what learning units you'd like me to cover, just drop me an email, then I'll focus the next collab on that. Excuse me. If I get a lot of emails or some emails at least coming through my way this week, then I'll schedule a lesson next week if you can go over the learning units that you want me to cover. There's another reason I also want you to do this is because it's going to force you to revise and go over your work. So if you can work through problems, that's the only way you'll actually know what you're struggling with. If you don't work through any problems, you don't know what you're going to be weak at, okay? So it encourages you to revise and do some work. So yeah, this is also going to give you some time to do some revision, and you can get back to me on the learning units you'd like me to focus on. The sooner you get back to me, the sooner I can prepare a collab around those learning units. All right, does it make sense? Everyone happy with that? Or any other questions? Your thoughts? Welcome your suggestions. Oh, sounds good. No worries. Oh, yeah, Kalisha, you actually did miss a lot. Sorry about that. To them. Okay. But Kalisha, you got the last part, right? About revise and then get back to me on the learning you want me to cover, okay? And then I'll go over that as part of the revision. Okay. Fantastic. Yeah, sometimes stress helps people, sometimes it doesn't. It's how you use it. But if you work consistently, it definitely reduces that stress, okay? It's not, whatever you can, the problems that you work through in your workbook and in your textbook, if you find that you can't be thrown something completely different in the exam. So don't think that you can be presented with something you've never seen before. No, Kalisha, I haven't uploaded anything. I was going to do it as part of my revision, but I can. I'll do that. Yes. Yeah. Exactly, Kai. All right. Um, okay, that's it from my side. And thanks for joining consistently. I really appreciate that. It is great having an audience, getting feedback during a live collab. So really appreciate you consistently joining. And yeah, we'll chat soon. This won't be the last one. So yeah, get back to me on the revision, and yeah, we'll see each other again. I'm very happy to hear that. That is my objective, that you enjoyed it. It's even better when you get to use it in the real world, but that's a bonus. But I'll take anyone enjoying it any day. No problem. All right, everyone. Have a good evening. Take care.